Hi, hello, welcome back to our channel. Now we are going to discuss about part 2 of the crash course of waves. So already you know that in previous class what is the principle of superposition. Based on that, now we are going to discuss about what is the stationary wave. Already you know in IPE and small definition that one. Two progressive waves are traveling in opposite direction. Both are superposed to each other. Then it gives what happens, a new wave, that is called the stationary wave or standing wave. And in this case it forms the nodes and antinodes. For stationary wave, two progressive waves are traveling in the opposite direction. Look here, we are taking two rigid supports. In between we are taking one string. When you pluck it down and leave it, what happens? One wave is going, progressive wave is going in forward direction. Because of this obstacle, always you remember that the waves are reflecting when the density is variation. If the wave is going in water, suddenly air is coming, it is coming reflected back. So when the obstacle is there, when the density variation is there, these waves are reflecting. Here like that, what happens? The wave is reflecting. This is the reflected wave is superposed to incident wave. This is called the stationary wave. Where the displacement is 0, it gives the node. Displacement is the maximum antinode. This is the node. This is the antinode. Like that we should observe alternate nodes and antinodes like this. Okay. Then we should apply the principle of superposition and we should find out the displacement of the stationary wave. Look here. Incident wave we are taking y1 equals to a sine omega t. Along the negative x-axis, positive x-axis we are taking minus kx. Then y2 equals to a sine omega t plus kx. Both are having same amplitude and same frequency also. Then from the principle of superposition we should add y1 plus y2 for getting the displacement of the stationary wave. So after simplification we are getting 2a sin kx cos omega t. It is very important for final IPE exams also. Then it should be right as cos omega t. What is as here? Not my name and your name. It is the amplitude of, this is the amplitude of stationary wave. This is the amplitude of stationary wave. See, what is the AS value? 2a sin kx. Just now I said it gives the alternate nodes and antinodes. Then what is the condition for node and what is the condition for antinode? Look here, if kx equals to n pi, n is the 0, 1, 2 like that we are taking. If we are taking n equals to 0, sin 0 equals to 0. N equals to 1, sin pi equals to how much? 0. So this is the condition for getting the displacement equals to 0. So in all these cases displacement is 0 means nodes we are getting. Like that, what is the condition for antinode? This is the condition for node. Means minimum displacement or 0 displacement. Like that, condition for antinode, what we are getting? Kx equals to 2n minus 1 pi by 2. N values we are taking 1, 2, 3 like that. Here we are getting the maximum. So this is the condition for antinode. And always you remember that the distance between two successive nodes, very important point, are two successive antinodes is how much? Distance between node to node or antinode to antinode is the lambda by 2. Like that, from the node to antinode the distance is the lambda by 4. Then now we are going to discuss about modes of vibration in stretched string. Modes means we have to know what is the definition for harmonics. Then what are the overtones and what is the fundamental frequency. First we are going to discuss about fundamental frequency. What is the fundamental frequency? We have to know about the concept, then only we can able to deal the problems. This is the revision of all these chapters. It's very useful for you for the preparation of NEET, mains and Eamcet also. Look, it has 2 nodes and 1 antinode. Node, antinode. After simplification, n equals to 1 by 2L into, instead of V, we are taking tension by linear density. This is the fundamental. What is fundamental frequency? The lowest frequency is called the fundamental frequency. Then if the frequency is integral multiple of fundamental frequency is how much? 1 by 2L into under root T by mu. It is one time of that fundamental frequency, means it is called first harmonic also. This is the first harmonic. So don't confuse. If they mention in problem first harmonic or fundamental frequency, both are same only. Harmonic means integral multiple of fundamental frequency. Fundamental means lowest frequency is called the fundamental frequency. Look here. Then we can go through the first overtone. One more term give, first overtone. What is the overtone? It is more than fundamental frequency. Same, it is called second harmonic. 2 times of that fundamental frequency is called the second. Look here. After simplification, you are getting N2 equals to 2 into 1 by 2L into under root T by mu. It should be right 2 times of N1. Like that, P segments are there. P segments, how to write this expression? NP equals to P into 1 by 2L into under root T by mu. So this is the fundamental frequency or first harmonic. This is the first overtone or second harmonic. Why 2 times of that fundamental frequency? This is 2 times of that overtone, means second overtone, third one. We can call third one is the second overtone or third harmonic. Like that, when we are taking the ratio of all these, N1 is, N2 is, N3 is 1 is to 2 is to 3. Not completed. Based on the fundamental frequency, we can say that what is the first law and what is the second law and what is the third law of harmonics. Look here. Vibrating string. First law is frequency is inversely proportional to length. Here we should write it N1 L1 equals to N2 L2. When condition is tension and linear densities are constant. Here T and mu are constants. Like that, second law is N is directly proportional to under root tension when length and linear densities are constant. It should be right N1 by N2 equals to under root T1 by T2 also. Like the third one is, here I am saying third law is, what is the third law? N is inversely proportional to under root linear density when here tension and lengths are constant. So this is about the complete stationary wave and condition for node, condition for antinode, and you will get the formula for amplitude of the stationary wave, fundamental frequency, first overtone, second overtone, and what is the ratio of the frequencies, and what is the distance between 2 successive nodes, and what is the distance between 2 successive node and antinode. So entire information is very useful for doing the problems. One problem we are discussing now. Find the fundamental frequency of the stretched string. How to find out this one? Suppose the given data is, they are giving length is 2 meters, tension is the 4 newtons. Look here. See, find fundamental frequency. Given data is, this is the 2 meters, tension is the 4 newtons, linear density is like 16 kg per meter. How to find out? Just now you know the formula, N equals to 1 by 2L into under root T by mu. So 1 by 2 into, instead of L, what we are taking? L is the 2. Under root tension is the 4. 16 is what? Linear density. 4. Your answer is 1 by 16 hertz. Like that we can find out. In some cases, if the lambda is, look here, find find the distance between two successive nodes or antinodes if lambda equals to 16 meters. Simply you can say that half of the wavelength is giving the distance between two successive nodes. So 16 by 2 is how much? 8 meters. How you should do the calculations I am explaining to you. Then sometimes see, if N1 equals to 4 Hertz, find second overtone frequency and third overtone frequency. Generally second means we are multiplying with 2. No, it's not right. First is the 2 times of fundamental frequency. Then third is the 3 times of that one. See, already you know the ratio. See, question is this one. How to find out? They have given N1 equals to this one. Second overtone means N3. N3 means 3 times of that 4. First one is the 12 Hertz. Third one means 4th frequency. So 4 times of that one is the 16 Hertz. Okay. Not only this one. If N1 equals to 4 Hertz, N2 equals to 16 Hertz, L1 equals to 2 meters, find L2. Here tension and linear densities are constant. What we are taking immediately, we know the formula N1 L1 equals to N2 L2. So N1 is the 4 into N2 is how much? 16 Hertz. Sorry, N1 L1 2. 16 into L2. After simplification, 1 by 2. L2 is 0.5 meters. So, depends on the given data. With the help of these formulas, we can give the solutions. This is about the stationary wave. Modes of vibration in open and closed pipe. So, what is open pipe? It is an organic pipe. Here, it is opened at both the ends. The pipe which is open at both the ends, that is called the which pipe? Open pipe. See, look here. How we can say about the open pipe? Look here. How the stationary wave is formed here? Look. Both the sides say open. Now the wave is going like this. Here the air is trapped and the waves are superposed and it gives the alternate nodes and antinodes. Where the displacement is maximum, you will get the antinode. Minimum or 0, that is the antinode. So always you should remember that at open end we are getting the antinode. Here also we can observe that fundamental frequency. How much? N1 equals to V by 4L. Then first, this is called first harmonic also. V by 2L. Next one is the first overtone. 2V by 2L. It should be right 2 times of N1. So don't think here instead of V we should write it under root T by mu. So whenever the string is coming we can write it instead of that wire, we can use that under root T by mu. Only here air is trapped. That's why no need of taking instead of V under root T by mu. Then second overtone N3 equals to 3 times of N1. So finally the ratio is N1 is N2 is N3 is how much? 1 is to 2 is to 3. Here if you want to draw, you can draw. This is about the first fundamental frequency. This is the second one we should draw like this. Then third one. So here 2 antinodes, 1 node. And here 3 antinodes and 2 nodes. So always nodes are one number is less than this one. This is about the open pipe. Then we should go through the closed pipe. What is the definition for closed pipe? The pipe which is closed at one end. As usual here air is trapped and both are superposed. Open end we are getting node, antinode, and this is the open end, always we are getting the antinode, node, antinode, node, antinode, node like this. But here fundamental frequency equals to our first harmonic N1 equals to V by 4L. Then second one is the first overtone. How much? N2 equals to 3 times of this one. That's why this is not calling the first overtone. It is the third overtone. 3 times of that one means third overtone. Same. This is the N2 equals to V by 3V by 4L. Like that. Fifth overtone. We should write it N3 equals to how much? 5 times of this. So finally you are getting N1 is, N2 is, N3 is how much? 1 is to 3 is to 5. So this is about the closed pipe. This is about the open pipe. Now how to find out the ratio of open and closed pipe of first fundamental frequency? N open pipe by N closed pipe. V by 2L divided by V by 4L. After simplification we are getting the 2. So N open pipe, frequency of open pipe is the 2 times of that closed pipe. And one more very important point in this, we should remember that end correction. When we are doing all these simplifications, exact starting position, the wave will start like that. No, actually some word extension we can observe this one. So how to do the end correction? That is called the end correction. End correction for closed pipe. We can take it that frequency N equals to V by how much? 4 times of this one. Whenever L is there, L plus 0.6 times of the radius of that pipe. This is for closed pipe. Like that, what is the end correction of this one? Open pipe. Both the sides are there, no? That's why 0.6 plus 0.6 you are getting V by 2 into L plus 1.2 into R. So this is about the open pipe and this is about the closed pipe. Now we are going to discuss about the beats. What are the beats? Two waves are propagating in the same direction, nearly equal frequency, not exactly. Then both are superposed to each other. Here both are traveling in the same direction, not opposite direction. Both are interfere and it gives the regular waxing and waning of the sound. Waxing means maximum sound, like large booming sound like that you are getting. Waning means small sound. Then once again large sound, then small sound. So alternate sounds we are getting. That is called the beats. Look here. This is one wave. Here frequency is the N1. And one more wave is superposed to this one. This is the N2. Here then what happens? Both are out of phase. Here varying of that sound. Here both are in phase like that. We are getting the maximum sound. Then here out of phase we are getting the minimum sound. So here what is the beat frequency? N1 difference N2. Why I am taking difference? Here N2 is more than N1. We should do the N2 minus N1. If N1 is more than N2, we should do N1 minus N2. Whenever you know the frequency, how to find out the time period between two successive waxing or waning? T delta T equals to 1 by N1 difference N2. And one more thing, time gap between two successive waxing and waning is half of this one. 1 by 2 into N1 difference N2. But based on this, they are giving the problems like this. Look here. Two tuning forks are there. First one frequency is, I am taking NA, and second one frequency is the NB. Before that, I want to say that what is the resonance? What is the resonance? If the body is vibrating with its natural frequency because of the influence of other body, that is other force, you can say, that is called the resonance. See, for a bomb detector and any radiation material, when we are going to shops, they are using some tags like that. Whenever the frequency is matched, it gives the sound. So all these belongs to resonance only. So only frequency is matching. Look here. We are taking two tuning forks. First one is the NA and second one is the NB. Then how to find out the beat frequency? Simply you can write it NA difference NB. But the problem is, here we are taking different cases. Look here. NA, we are adding some wax. We are adding some wax like this. Then what happens? Generally frequency of NA is decreasing like this. The questions they are asking like this. See, NA equals to 400 Hertz. NA equals to 400 Hertz. Then NB, we have to find out the frequency of this NB. See, otherwise we should add here. NB we have to find out. Beginning frequency is 4 Hertz. Then after adding the wax, delta N dash equals to 3 Hertz. How to solve this type of problems? It is very important concept. Then what are the uses of the beads? We can repair the musical instruments. We can find out the dangerous gases in mines. We can use the for some special effects. We are using the beat concept. So these are the, we can find out the unknown frequency of the tuning fork. All these belongs to the applications of the beats. Look here. How to find out the NB? Look here. We know the frequency of NA. We know the frequency of, we don't know about the NB. See, we are adding wax to NA. Look. So, NA, NB, we can say that 400 plus or minus 4. Means your answer is 404 or 396. We got two answers, but only one answer is right. How to find out this answer? Look here. Whenever we are adding this wax, then beat frequency is how much? 3 Hertz. Now what is the beat frequency of this one? When we are adding 3 to this one. So NB dash equals to NB dash equals to how much? This is 403 and this is the 397. 397 NA we are finding. They have given NB. They have given NB equals to 400 Hertz. How to find out this one? Look here. NA value is either 404 Hertz or 396 Hertz. But whenever we are adding wax to NA, same condition you can apply for B also, nothing will happen. Same concept. See, here 404 to 403. Here decreasing. But here 396 to 397. It's never possible. Whenever we are adding the wax, then what happens? Number of beats are decreasing. Okay. But in this case it is increasing means. So what is the frequency of this NA? NA equals to 404 Hertz. Like that. One more problem we will do. See, here NA equals to 300 Hertz. Beat frequency is 5 Hertz. After adding the wax to this B, we are adding this one. Then beat frequency NA dash difference NB dash is nothing but 6 Hertz. Find the beat frequency of NB. So NB value how much? 300 plus or minus 5. Don't take this one. Original only we can take it. So NB equals to 305 Hertz or 295 Hertz. How to find out which is the right one? Look here. When we are taking the 6, this is 306 Hertz and this is the 294 Hertz. Whenever we are adding wax to B, beat frequency is decreasing or increasing? Generally it is decreasing. So here instead of that it is increasing. It is the wrong answer. Our right answer is how much? Our right answer is the 295. Why? Here it is decreasing. Okay. Then discuss reverse of that adding the wax. We have to filing that one. Means we have to short that any one of the tuning fork and how to find out the frequency. Look here. We are taking two tuning forks. This is the NA. This is the 400 Hertz. And this is the NB. We don't know about this one. Then what happens? They have given beat frequency is how much? NA difference NB is the 7 Hertz. After filing of B, means we have to short this one. That beat frequency they have given how much? Delta N dash is 6 Hertz. Then how to find out the NB? So NB what we are taking? NA plus or minus 7. So 407 Hertz. Our answer is 407 Hertz, or this is 393 Hertz. Which one is correct? We can't say. But with the help of the given hint, look here. When we are adding, NB dash is how much? NA is how much? 400. 400 plus 6 how much? 406 Hertz, or 394 Hertz. Whenever we are shortening that, then what happens? Frequency is generally increasing. Here you see, this is 407, this is the 406. It's wrong. Here it is increasing, reverse of that waxing. So our answer is how much? 393 Hertz. So like that we can able to find out the beat frequency of the unknown tuning fork. Then we are going to discuss about the Doppler effect. They have deleted this topic for Eamcet, but for NEET and other competitive mains exams, you have to prepare this one. First of all, what is the Doppler effect? The apparent change in the frequency due to relative motion between the source and observer is called what? Doppler effect. Doppler effect. Apparent change in frequency due to relative motion. Due to relative motion between source and observer. S belongs to source and O belongs to observer. Where we should observe practically, you are on the platform of railway station. Train is moving towards you. The horn sound is increasing. Same observer, same source. If the train is moving away from you, what happens? That sound is decreasing. So here the change in frequency is due to what? Relative motion between the source and observer. That is called the Doppler effect. Here you can take one common formula. N dash equals to N into V plus or minus V naught by V plus or minus Vs. Look, N dash is the apparent frequency. This is the apparent frequency. N is the original frequency. Original frequency. Then V is the velocity of sound. V is the velocity of sound. Vs is the velocity of source. Like train, no, here source whatever producing the sound. Even bus horn also you can take it. Then V naught is the velocity of the observer. Then look here, different applications we are getting here. See, first one is, if observer is moving towards the stationary source. Stationary source means immediately velocity of source is how much? Vs equals to 0. That too observer is moving towards this one means N dash equals to what we are getting? N into V plus we are taking. Because whenever observer is coming towards the source, the sound is increasing. So numerator is more. We are taking the plus here. Second case, you look here. If observer is moving, look here, arrowhead, from the stationary source. Here also Vs equals to 0. When that observer is moving, observer is moving away from the stationary source, sound is decreasing. So here N dash equals to N into what we are getting? V minus V naught by V. Here apparent frequency is greater than original frequency. Here apparent frequency is less than original frequency. Third case, look here. Observer is moving towards the source and source is moving towards the observer. Here N dash equals to what we are taking? N into numerator is more value. Both are moving towards each other. More frequency means denominator is the less and numerator is the more. So here V plus V naught by V minus Vs. Here N dash is greater than N. Like that Fourth case, observer is moving away from the source and source is also moving away from the observer. Here n dash equals to n into numerator is the minus, denominator is the plus. So n dash is less than n. If we should consider the wind also, wind velocity n dash equals to n into v plus r minus w plus r minus v naught by v plus r minus w plus r minus vs. If the wind is along the direction of velocity of sound, you can take plus. If the wind is opposite to that one, you can take the minus based on the situation. And some cases, no, this v and v naught both are v naught and vs, our velocity is perpendicular to this one, means you can go through the parallelogram law of addition of vectors. Thank you everyone. Hope you understand this. You can able to understand this part 1 and part 2 of the waves. In future I will discuss the previous year's problems also.